Hello, my name is Jack Canniff, and for my Orgo 3 presentation, I'm doing the benzoin and Stetter reaction. Here is the benzoin reaction, where you have two aromatic aldehydes reacting with a catalyst to create a benzoin molecule. In this case, the catalyst I'm going to be using is either NaCN or KCN, but it can also be done using thiazonium salt and NHC. The R groups on the aromatic aldehydes can be either a tertiary alkyl, an aryl group, or a heteroaryl group. Basically anything that won't have an alpha proton in the R position. And yeah, we'll be moving to the mechanism for the benzoin reaction. Alright, behind me is the benzoin mechanism. Now the first step of this mechanism is that the NaCN will dissociate into a cyano group, and this cyano group will attack the carbonyl of the aromatic aldehyde, moving the electrons up to the oxygen, creating this molecule here. And from here a proton transfer will happen, in which the negated oxygen will attack the hydrogen down here, breaking this bond and moving the electrons to this carbon center, negating the carbon and allowing it to attack the other aromatic aldehyde as such, moving the electrons up to this oxygen, creating this molecule here. And now the molecule will undergo another proton transfer, in which this oxygen group will attack this hydrogen, breaking this bond and negating this oxygen over here, creating this molecule. And this will allow the molecule, or the oxygen rather, to move its electrons down, kick off the cyano group, and net us our benzoin molecule. And from here, we'll move on to the Stetter reaction. Alright, behind me is the Stetter reaction, in which an aromatic aldehyde will react with an alpha-beta unsaturated ketone, and when exposed to NaCN, it will create a diketone molecule. The R groups in this case will also be, just like the benzoin reaction, a tertiary alkyl, aryl group, heteroaryl group, just no alpha protons in this one. And we'll be moving to the mechanism for this guy. Alright, behind me is the Stetter mechanism. Now this mechanism is very similar to the benzoin reaction, in which the first step, an NaCN will dissociate into a cyano group. This group will attack the aromatic aldehyde, thus negating the oxygen and causing the proton transfer in the next step, which will negate this carbon here. But instead of attacking another aromatic aldehyde, it will attack an alpha-beta unsaturated ketone, attacking the double bond here, moving the electrons over because of resonance, and negating the oxygen. And now another proton transfer will happen through a really long line, attacking the oxygen, or the hydrogen over here, negating the oxygen, creating this molecule, in which the negative oxygen, or the negative charge on the oxygen, will come down, kick off the cyano group, and then through tautomerization, which will reduce the double bond, recreate the carbonyl here, and get rid of the hydrogen, will give us our final product. And now I'll talk about the comparisons and differences between the Stetter reaction and the benzoin reaction.
To finish my Orgo 3 presentation, I'll be comparing and contrasting the benzoin and Stetter reactions. As for comparisons, both reactions use the same reagents, such as NaCN or KCN, or just using thiazolium salt. Both reactions use the same starting material, an aromatic aldehyde, and both reactions undergo very similar processes, such as using the cyanide as a nucleophile, doing 2 proton transfers, and having an addition and an elimination. As for differences though, both have slightly different starting materials, such as the benzoin reaction having another aromatic aldehyde versus the Stetter reaction using the alpha-beta unsaturated ketone. Both reactions undergo slightly different steps, such as the benzoin using the addition reaction versus the Stetter using the Michael reaction. And finally, the final products look slightly different, such as benzoin just creating the benzoin molecule versus the Stetter making a diketone. And finally, here is my name the reaction practice problem.